Ever feel like everyone's suddenly fluent in AI? Like they're all having this conversation you can barely follow? Well, today we're diving into the core of it, machine learning.
And don't worry, no need to be a coder to get this.
Yeah, we'll break down what machine learning really means, how it's already woven into your daily life.
And where things get really, really mind-bending.
So our source material dives into the three main types of machine learning: supervised, unsupervised, and reinforcement.
Okay, I'm not gonna lie, it does sound a bit like we're, training robots for a sci-fi film.
Yeah, I can see that. But the truth is, these three types of learning are fundamentally different, and understanding them is key to unlocking the mysteries of AI.
Okay, so let's unpack this. What exactly is supervised learning?
So supervised learning.
Our sources describe it as, like, teaching with labeled data.
It almost sounds too straightforward to be true.
Think of it like this. Imagine showing a child a bunch of pictures and saying, this is a cat, this is a dog, this is a bird. You're giving them labeled data. In supervised learning, we do the same thing with machines.
Okay, so we're feeding them information.
We feed them tons of labeled data, and the algorithm learns to identify those patterns and make predictions on new, unseen information.
So if I show a supervised learning model enough pictures of cats, it'll eventually be able to identify a cat in any image, even if it's never seen that specific cat before.
Precisely. And it's not just about images. This principle applies to all sorts of data. For example, think about those spam filters in your inbox.
Oh, yeah.
They've been trained on huge data sets of emails labeled as spam or not spam, and they use that learning to predict whether a new email you receive is likely to be junk.
That makes total sense. So it's all about recognizing patterns and making predictions based on labeled examples.
Yeah.
What about unsupervised learning? How do you teach a machine without giving it any labels?
These are great questions.
It's like, go figure it out, kid.
Yeah. Unsupervised learning is fascinating because it's about uncovering hidden structures within data, even when we don't know what we're looking for.
Okay,
Imagine you're a detective at a crime scene.
right.
You have a bunch of clues, but you don't know who the culprit is or what their motive might be.
Intriguing. So how does our algorithm detective crack the case?
Instead of looking for specific answers, unsupervised learning algorithms search for patterns and relationships within the data itself.
Okay.
Think about those personalized recommendations you get on streaming services or online stores.
Yeah, like because you watch this.
Exactly. They're based on unsupervised learning algorithms, analyzing your past behavior and the behavior of millions of other users to identify hidden connections and predict what you might enjoy next.
It's like they're connecting the dots, even when we don't see the dots. That's pretty remarkable. Okay, so we've got supervised learning, teaching by example, and unsupervised learning, finding hidden patterns. What about reinforcement learning? This one sounds a bit more experimental.
It is. Reinforcement learning is all about letting machines learn through trial and error, much like how we learn many things in life.
Right.
Imagine teaching a dog a new trick.
Hmm?
You don't give it a textbook on canine obedience. You reward it for good behavior and maybe give it a gentle correction when it gets things wrong.
Right. It's all about positive and negative reinforcement. But how does that translate to the world of machines? Do we give them virtual treats?
Well, not quite virtual treats, but the principle is similar. In reinforcement learning, the machine or agent interacts with an environment. It takes actions, and based on those actions, it receives feedback in the form of rewards or penalties.
So if it does something good, it gets rewarded, and if it messes up, it gets penalized. But how does it know what's good or bad in the first place?
That's the beauty of it. We define the goals, but we don't tell the machine how to achieve them. Let's say we're training an AI to play a game.
Good.
We can program it to know that winning is good and losing is bad, but we don't tell it the best strategies to win. It has to figure that out on its own through trial and error.
So it's like throwing it into the deep end and letting it learn to swim by experimenting and figuring out what works best. That's a pretty cool, albeit slightly terrifying way to learn.
It is. And it's led to some incredible breakthroughs in AI. Take AlphaGo, for instance.
Okay.
It learned to play the incredibly complex game of Go at a superhuman level using reinforcement learning. It played millions of games against itself, constantly refining its strategies based on the outcomes.
Okay, that's seriously impressive and a little intimidating, if I'm being honest. So to recap, we've got supervised learning, which is like teaching with flashcards, unsupervised learning, which is like finding patterns in a sea of data, and reinforcement learning, which is like teaching a dog new tricks but for machines. Did I get that right?
You absolutely did. You've just taken your first steps into the fascinating world of machine learning.
This is already blowing my mind, and we've just scratched the surface.
And believe me, it gets even more interesting.